All right, folks, this is day number 5, part 1. I want to touch in this video just on absolute convergence. I'll get to power series and the rest of this stuff on day number 2. Okay, so this lesson right here will just be day number 1, absolute convergence. Very easy topic, so let's get started. Good practice quiz that you can use to go ahead and do a little work with finding error and using some of your tests for convergence as well. Okay, so absolute convergence. All that absolute convergence means is that if the series u sub n from n equals 1 to infinity and so if an alternating series and its non-alternating series partner, so to speak, both converge, it's absolutely convergent. So let's look at an example. Here's an example of absolute convergence. Absolute convergence. So let's say we took the sum from n equals 1 to infinity of the alternating series negative 1 to the n over n squared. Okay, we would have to prove the two things. It's decreasing, and the limit as n goes to infinity of 1 over n squared equals 0. Just for the purposes of this portion of the video, let's say check and check. Okay, therefore the alternating series is convergent. Okay, so that's convergent. Okay, to test for absolute convergence, you would also test the non-alternating version of the same series. Of course, that would require us to do a different test, right? Not the alternating series test. That would require, in this case, I would probably use the integral test, 1 to infinity, or I could look at it and say, dang, that's a p-series. That's a p-series, convergent p-series. So that converges. Okay, if both of them converge, then it's absolutely convergent. If only one of them converges, then it's what we call conditionally convergent. Conditionally convergent. An example of conditional convergence is the following. Okay, this is a classic one. Alright, so we know that the harmonic series, if it's non-alternating, this is divergent. It's the harmonic series. Okay, but the alternating harmonic series is convergent. So this one converges and this one diverges, therefore it's conditionally convergent. Now, one quick thing. If the non-alternating series converges, the alternating series will always converge. Okay, so what I would do is I would always check the non-alternating series first. Check that one first. If it converges, you know it's absolutely convergent. If it diverges, then you'd have to check the alternating series to see if it diverges or converges, right? And if it converges, then of course you'd have conditional convergence. So let's move on to the next slide. Okay, basically what I had just said a moment ago. Okay, so your first step should always be check the non-alternating series for convergence. If you get convergence for the non-alternating series, then you know you have absolute convergence. That ensures that the alternating series will converge. So you'd have absolute convergence. And you'd be done. Okay? If that diverges, then what I would do is I would check the step 2. In this case, I would check the alternating series. Okay, if that converges, then you have conditional convergence. Conditional convergence. If it diverges, then, well, you've got a dumb series that neither diverge or neither converge, so you'd just be divergent. So you kind of have a two-step process there, but always start with the non-alternating series. Okay, absolute and conditional convergence. This is just clearly laying out this idea of conditional convergence and absolute convergence. Okay, likewise here, this is the gist of what's going on in this page, along with part of a proof. If a series is absolutely convergent, then it's convergent. Oh, great. Thanks for that. That's pretty clear. And then a little bit more of a proof. Okay, now this is kind of a conundrum a little bit. This series right here is not technically alternating every term, but it has different signs along the way, but it's not technically alternating. You don't typically see examples like this, but it's a good one to see, just to be aware of. Okay, it's not alternating, so we can't necessarily use this idea of the alternating series tests. But we can still test for absolute convergence, okay? So what I can do, though, is I can say that this is true because cosine of n it'll oscillate, right, between +1 and -1. So the absolute value of cosine of n over n squared would always be less than or equal to that. And since we know this is a convergent p-series, then by the comparison test, okay, then this has to be convergent. Therefore, by the theorem of absolute convergence, what we saw on the last page, that would also have to be convergent, okay? So it's kind of an odd example, not one you'll typically be tested on, but good to be aware of. All right, let's look at a homework problem here. Let's look at number 7a. All right, so again, like I said, test the non-alternating series first. All right, so I'm going to test the non-alternating series. That would be the series from n equals 1 to infinity of 3 to the n over n squared. Oh gosh, what is that screaming to you? To me, that's screaming ratio test. Ratio test for sure, all day long. So that would be the limit as n goes to infinity of 3 to the n plus 1 over n plus 1 factorial. Remember, divided by the nth term, but I'm going to multiply by its reciprocal. That would be n factorial over 3 to the n. Okay, so as I look at that, I'm going to do a little bit of cancellation. Let me do some rewriting. This would be 3 to the n times 3 times n factorial over n plus 1 times n factorial times 3 to the n. All right, let's do some reducing. 3 to the n's cancel, n factorials cancel. Oh goodness, look at that. The limit of that as n goes to infinity, clearly the denominator will become massive. The numerator stays as 3, so that would be 0. And therefore, this series right here would converge. Since the non-alternating series converges, then I would say that this series right here, n equals 1 to infinity of the alternating series, I think it was n factorial, will be absolutely convergent. Absolutely convergent. You don't have to go any further with that one. Okay, let's take a look at part C here. This is a funky one. All right, so let's check its non-alternating series, which would be the following. N equals 1 to infinity of arctan of n over n cubed. We're going to have to do a comparison test here. Integral test, not looking good. Ratio test, not looking good. I'm going to go with a comparison test, and let's see here. I would probably go with, let's see, what would the maximum value of arctan be on its domain? Well, it would be pi over 2, right? So arctan of n over n cubed would always be less than or equal to pi over 2. Pi over 2 over n cubed. Okay, so since the sum from n equals 1 to infinity of 1 over n cubed is a convergent p-series, then that would mean that pi over 2 times that series would also have to be convergent. Would also converge. Okay, just coefficient out in front times a finite sum will just be a finite sum. Therefore, by comparison test, okay, and this is not a formal write-up, but therefore by the comparison test, then that would mean that the sum from n equals 1 to infinity of arctan of n over n cubed will also converge. Therefore, its alternating series, okay, and that would converge, like I said, by comparison test. Its alternating series, negative 1 to the n, arctan of n over n cubed, will converge. There, and thus would be absolutely convergent. Awesome. Those are really good examples. I would, if I were you, as I said, just go ahead and test the non-alternating series first. But when you do that, when you test the non-alternating series, it opens the door. It swings that door wide open, right? It just creaks that door open to all your convergence tests. All right, then it's game on. So you've got your integral test, integral, I guess I'll write it out. Integral test, you've got your ratio test, you've got your limit comparison test, you've got a normal comparison test, you've got any means possible. If it's a geometric series, anything like that, it opens the door to convergence. All right, that's it for part 1 of day number, what is this? I don't even know what day this is. Day number 5 on